Hello, everyone, and welcome back. I hope you've been enjoying the journey so far because today we're going to learn another one of the most important concepts in programming. So far, our Python programs have become much smarter. Let's think about everything we've learned until now. Our programs can display information using print, store information in variables, accept user input, perform calculations, compare values, and make decisions using if, elif, and else. That's already enough to build some useful programs, but imagine I asked you to write a program that prints hello 10 times. Would you do it using only what we've learned? One option would be to just straight up write 10 print statements. Does it work? Yes. Is it a good solution? Not really. Imagine now I ask you to print hello 100 times or even 1,000 times. Would you really want to write 1,000 print statements? Of course not. So there has to be a better way. That's why loops exist. Today we are going to learn how to make our programs repeat tasks automatically. By the end of this lesson, you'll be able to create programs that repeat instructions hundreds or even thousands of times while writing only a few lines of codes. So let's get started. So before writing any code, let's think about the repetition in everyday life. Many things around us repeat the same actions over and over again. For example, imagine a washing machine. It doesn't just wash your clothes once, instead it repeatedly fills with water, spins, drains the water, and repeats the cycle until the washing process has been done. Or think a clock. Every second it updates the time. It repeats the same process continuously. A traffic light also repeats a sequence. Green, yellow, red, then it starts all over again. Even in video games, repetition is happening constantly. A character keeps moving while you're holding a key, say W. Enemies continuously patrol an area, coins keep spinning, animations play over and over again. Programs often need to repeat actions. Instead of writing the same code again and again, programmers use loops. So what exactly is a loop? A loop is a programming structure that repeats a block of code. Depending on the type of the loop, it either repeats while a condition is true or for a specific number of times. Think of a loop as someone asking the same question repeatedly. Should I continue? If the answer is yes, the loop runs again. If the answer is no, the loop ends. The first loop we'll learn about is called the while loop. The syntax looks like this: while condition, and the code we need to repeat will be indented right under it. Let's understand this. The word while is a Python keyword. After it comes a condition. As long as that condition remains true, Python keeps repeating the indented code below the said condition. The moment the condition becomes false, Python exits the loop and continues the rest of the program. Think of it like this: while something is true, keep doing this. It's that simple. So let's write our first loop. Before running the program, let's predict what will happen. First, we create a variable called count and give it the value 1. Next, Python checks that is count less than or equal to 5. Yes, so the Python enters the loop. It prints 1. Then this line executes, count plus equal to 1. This increases the value by 1. Now the count becomes 2. Python reaches the end of the loop. But instead of stopping, it goes back to the top. Now it asks again, is 2 less than or equal to 5? Yes. So it prints 2, then increases the count again. This process repeats until the count becomes 6. At that point, Python asks, is 6 less than or equal to 5? No. The condition is false. So the loop ends. Now let's go ahead and run our program and see what the output is. So as you can see in the output, we got 1 to 5. Amazing. With only 4 lines of code, we have printed 5 numbers. Now let's slow things down and watch exactly what happens inside the loop. In the first iteration, the count is 1, and the condition, following the same logic as a previous example, the loop stops. Each complete repetition of a loop is called an iteration. So this loop performs 5 iterations. You'll hear the word iterations frequently in programming, so it's useful to remember it. Now let's look closely at the highlighted line, the line count plus equal to 1. This line might seem small, but it's one of the most important part of the loop. Why? Because it changes the condition. Without it, the value of count would never change. Let's see what happens if we remove it. Now I'm going to save the program and let's run it. And as you can see, the count starts as 1. So the Python checks, is 1 less than equal to 5, which is true. So it prints 1. Then what? Nothing changes, as count is still 1. So Python checks again, still true, print 1. Again, again, and again. The condition never becomes false. The loop never ends. This is called an infinite loop. To exit out of an infinite loop, which you might have caused accidentally, simply press Ctrl C. Simply go over the terminal, click on it, and press Ctrl C to exit an accidental infinite loop. An infinite loop is exactly what it sounds like, a loop that never stops. Here's the code again. If you run this program, your screen will quickly fill with 1, 1, 1, and it continues forever until you manually stop the program. Infinite loops are one of the most common beginner mistakes. Whenever you write a while loop, ask yourself, will my condition eventually become false? If the answer is no, you've probably created an infinite loop. Now let's build a slightly more interesting program, a countdown timer. Now let's understand it. The counter starts at 10. Each iteration decreases it by 1. When the counter reaches 0, the condition becomes false. Then the program continues. Now let's run it and see what the output is. And as you can see, we got a countdown in reverse, and eventually we got the message blast off. This is similar to how countdown timers work before a rocket launch. Loops make tasks like this incredibly easy. Loops aren't just for printing values, they can also perform calculations. Let's find the sum of the first 5 numbers. Initially, the total is equal to 0, and in the first iteration, 0 plus 1 is equal to 1. Second, the 1 plus 2 is 3. In the third, 3 plus 3 is 6, and fourth, 6 plus 4 is 10. And eventually, after the fifth iteration, 10 plus 5, it becomes 15. Now let's try to run this program and see what the output comes out to be. And as you can see, I got the output 15. In the previous section, we learned our very first loop, the while loop. We discovered that a while loop keeps repeating as long as the condition remains true. It was perfect for situations like a countdown timer or repeating something until a condition changes. However, many times in programming, we already know exactly how many times we want something to repeat. For example, printing the numbers from 1 to 10, displaying a multiplication table with 10 rows. Print every student in a class list. In situations like these, writing a while loop can feel a little unnecessary because we have to manually create and update a counter. Python gives us a much simpler option. It's called the for loop. Let's learn how it works. So a for loop repeats a block of code for every item in a sequence. Don't worry too much about the word sequence yet. For today's lesson, you can simply think of a sequence as an ordered collection of values. For example, 1, 2, 3, 4, 5, or A, B, C, D. The for loop automatically moves through each value one by one. Unlike a while loop, we don't usually need to manually increase a counter. Python does that for us. This makes for loops shorter, cleaner, and easier to understand. The basic syntax of the for loop looks like this. Let's understand each part. For is a Python keyword. Variable stores the current value during each repetition. In tells Python where to get the values of the sequence from. And the sequence is the collection of values we'll loop through. The colon starts the loop block, and the indented code runs once for each value. At first, this might seem a little confusing, don't worry. Once we start writing examples, it becomes rather easy. So now more on the sequence is that where does the sequence come from? One of the most common ways is by using the range function. Range generates a sequence of numbers. For example, range bracket 5 creates the numbers from 0 to 4, that is 0, 1, 2, 3, 4. Notice something important. It stops before 5. This surprises many beginners. A simple way to remember it is that the range parenthesis stop starts at 0 and stops before the number you provide. Now let's combine for and range to build our very first for loop. Before running it, let's predict the output. The range parenthesis 5 creates 0, 1, 2, 3, 4. The loop runs once for each number. During the first iteration, number is equal to 0. So Python prints 0. Next iteration, number is equal to 1. So Python prints 1. This continues until the final value. Now let's run the program and see what the output is. And as you can see, we got the numbers from 0 till 4. Notice that we never wrote number plus equal 1. Python handled that automatically. That's one of the biggest advantages for loop. Sometimes we don't want to start at 0. Suppose we want to print the numbers from 1 to 5. We can simply write as follows. As you can see at the highlighted bit, I've just gone ahead and replaced 5 with 1, 6. Let's understand this version. The first number is the starting value and the second number is the stopping value. But remember, it is not included. So range 1, 6 produces 1, 2, 3, 4, 5. Now let's run the program to confirm and let's see. And there you go. It is printed 1, 2, 3, 4, 5. This form of range is probably the one you'll use the most often. The range function has 3 common forms. The first form being range parenthesis, a number, say 5, which will print out 0, 1, 2, 3, 4. The second form is range parenthesis, the starting number, comma, the stopping number. And the third form is the starting number, comma, stopping number, comma, step. The third value is called the step. It tells Python how much to increase after each iteration. Instead of increasing by 1, Python will increase the value by 2. This is very useful for printing even numbers or even skipping values. Now let's make a program utilizing the step value to print even numbers. As you can see, I've taken 2 as the starting number, 11 as a stopping number, as I just want even numbers till 10. And 2 is the step index. Now let's run the program and see if it actually prints the even numbers from 1 to 10. And as you can see, it is just printed out all the way from 2, 4, 6, 8, 10. Notice that every number is even because the loop increases by 2 times. Because the loop increases by 2 each time, our numbers are automatically skipped. Also, did you know that loops can also count backwards? It is done using a negative step index. Let's try this. Now, as you can see, I've replaced the starting number to be 10 and the ending number to be 0, and the step index is -1. That is, the loop will begin at 10, stop at 0, that is, it will not print 0 and it will move backwards by 1. Now let's run the program. As you can see, the output, the negative step, tells Python to count backwards instead of counting forwards. Now let's build a first useful project using a for loop. We'll create a multiplication table generator. Suppose the user enters 5. The output should be 5x1 equals 5, 5x2 equals 10, all the way till 5x10 equals 50. Now pause the video right here and try it for yourself. Now as you can see, I first took a variable number in which I would prompt the user to enter any number, after which I declared a for loop in which the range began from 1 all the way to 11. Inside of which I've used the print statement and written number, comma, x for multiplication, comma, I being the iteration we are currently on, and then equals number into I to actually calculate the product of those two numbers. Now let's go ahead and run our program. Now let's enter in a number, let's see, 5, enter. And as you can see, it works just fine. With just one loop, we've created an entire multiplication table. Imagine writing this without a loop. You need 10 separate print statements. Now, similarly to while, for loops aren't only for printing values. They can also perform calculations. So now pause the video and try to implement the same program that we implemented in while by adding the first 10 digits. At this point, you might be wondering, when should I use while loop and when should I use for loop? Here's a simple rule. Use a while loop only when you don't know how many times the loop will repeat. The loop depends on a condition becoming false, or you're waiting for the user input or an event to take place. For example, password attempts, number guessing games, waiting for a file to download. And use a for loop when you know the number of repetitions, you know that you're looping through a sequence, and you're counting. For example, multiplication tables, printing numbers, processing a list of items. Both are useful. Choosing the right one makes your code easier to understand. So in the previous section, we learned how to use the for loop along with the range function to repeat tasks a specific number of times. We created multiplication tables, counted forwards and backwards, and learned the different forms of range. But what if one loop is not enough? Imagine you wanted to create a chessboard. Print rows and columns of numbers or draw shapes using stars. One loop can only repeat in a single direction. To solve more advanced problems, we sometimes need a loop inside another loop. That is called having a nested loop. Although nested loops may sound complicated, they are actually quite simple once you understand how each loop works. Let's dive in. So a nested loop is simply a loop inside another loop. Think of it like this. Imagine you're a teacher taking attendance. So first you visit classroom 1 and call every student's name. Once you're finished, you move to classroom 2 and again call every student's name. Then classroom 3. So the process looks like this. You first go into classroom 1 and then to iterate through each student. Then you iterate through the classroom and again you iterate through each student. Notice something important. For every classroom, you go through every student before moving to the next classroom. That's exactly how nested loops work. Let's look at the basic structure of nested loops. This code contains two loops. The first loop is called the outer loop, and the second loop that is nested is called the inner loop. The outer loop controls how many groups there are, and the inner loop runs completely every single time the outer loop repeats. Let's trace the execution. When I equals 0, the inner loop runs and it goes from j equal to 0 all the way till the end of the loop. Then the outer loop continues again. Now I goes from 0 to 1. Again, the inner loop starts over and goes from j equal to 0 to all the way till the end. Finally, when I is equal to 2, the inner loop repeats again. Notice that the inner loop completed 5 separate times, one time for each value of I. A good way to imagine nested loops is using a clock. Think about the hour hand. Every hour, the minute hand completes a full circle. For example, 1:00, 1:01, 1:02 to represent the numbers. The minutes complete an entire cycle before the hour hand changes. That's exactly what happens with nested loops. The inner loop always finishes completely before the outer loop continues. Remember this rule. It will help you understand every nested loop you'll ever write. Now let's build our very first pattern using nested loops by printing a square. Don't worry if the end is equal to quotation marks part is unfamiliar. We'll explain it later. Normally, print moves to a new line after printing. For example, print asterisk produces one after the other in a new line. But when we write print asterisk comma end equals quotation marks, just as I've written right here, Python prints the star without moving to the next line. This allows the stars to appear beside each other in the same line, instead of skipping over into the other line and printing it like a tower. The second print with empty parentheses moves to the next line after each row is finished. So now let's run the program and see the output. And as you can see, we get a square. Well, it doesn't look like square, but if you count each row and column has exactly 5 asterisks. Now, as you can see, the thickness or the length is dependent upon the range we have used. In this case, I've used 5. Now let's understand exactly what's happening. The highlighted line creates 5 rows. Each time a new row begins, the inner loop runs. The inner loop is what prints the 5 stars. After printing the 5 stars, Python reaches print parenthesis, which moves to the next line. Then the outer loop repeats and another row begins. Eventually, 5 rows are printed by the inner loop. A simple way to remember this is that the outer loop is equal to rows and the inner loop is equal to the columns. You'll use this idea again and again. Now I have an assignment for you. It may be a little difficult. Now go ahead and try to print a triangle this time, utilizing the same principles we've used to print a square. So far in this lesson, we've learned 2 powerful types of loops. We learned the while loop, which repeats while a condition is true, and we also learned the for loop, which is perfect when we know how many times we want to repeat something. Finally, we combine the loops together using nested loop to create patterns and tables. But what happens when we want to change the normal behavior of a loop? Imagine you are searching for your friend in a crowd. As soon as you find them, do you keep searching through everyone else? Of course not. You stop searching immediately. Or imagine you're reading a list of names, but one name is blank. Instead of stopping completely, you simply skip that name and continue reading the rest. Programs often need this kind of control as well. Sometimes we want to stop a loop early or skip one particular repetition or leave a placeholder for a code we'll write later. Python gives us 3 special keywords to do exactly that: break, continue, and pass. Let's learn exactly how each one works. Normally, a loop follows a simple pattern. Start loop, run the code, go back, and repeat until finished. But sometimes we don't want the loop to follow this pattern. For example, a login system should stop asking for password once the correct one is entered. A game should stop searching once an enemy is found. A calculator should ignore invalid input and continue asking for another value. Instead of always following the normal path, we sometimes need to interrupt or modify the loop. That's where the loop control statement comes useful. The first control statement is break. The purpose of break is simple. It immediately exits the loop no matter how many iterations are left. Its syntax is very simple. Just simply write break. Whenever Python reaches the break statement, it immediately leaves the loop and continues executing the code you've written after the end of that loop. Think of a break like pressing the emergency stop button on a machine. Everything inside the loop stops immediately. Now let's take a look at an example using break. Before running the program, let's predict the output. The loop starts with number is equal to 1. Is 1 equal to 6? No. So the Python prints 1. Next, number equals 2. Again, not 6. So it prints 2. This continues until the number is equal to 6. Now the condition becomes true and Python executes break. This will immediately end the loop. So the output will only be 1, 2, 3, 4, 5. Now let's try and actually run the program. And as you can see, we got the same output. Now let's build a rather simple password checker. Now let's understand the code that I've just written. The loop keeps asking for the password, and if the password is incorrect, the loop keeps repeating. Once the correct password is entered, Python prints access granted. Then break immediately exits the loop. Without break, the program would continue asking for passwords forever. Now let's run the program and actually see if the program keeps prompting me again and again. And as you can see, the program has prompted me, but I won't be giving it the right answer. So I'll just type some random things and hit enter, and as you can see, it's asking me for the password yet again. So now I'll enter something else and hit enter, and it's still asking me for the correct password. So now let's see if entering the correct password will actually stop it. And you can see the program exited. Now let's learn about the continue. Unlike break, continue does not stop the loop. Instead, it skips the current iteration and moves directly to the next. Think of it like a teacher reading attendance. If one student's name is unreadable, the teacher simply skips that name and continues with the next student. That's exactly what continue does. It skips one repetition but keeps the loop running. Now let's build an example utilizing the continue. This program skips the even numbers, thus another method to print out odd numbers. Remember the modulus operator? It gives us the remainder after division. Even numbers leave a remainder of 0 when they're divided by 2. Python encounters an even number and it executes continue and skips printing it. So the output should be only the odd numbers from 1 till 10, excluding 10, that is. So now let's run the program. And you can see I got 1, 3, 5, 7, and 9. The third control statement is pass. At first, it seems a little strange. Unlike break and continue, pass does absolutely nothing. So why does it exist? Sometimes you're planning your code, but you haven't written all the code yet. Python requires every block to contain at least one statement. If you leave it empty, Python will give you an error. Instead, you can temporarily write pass. This will act as a placeholder until you're done to add real code later on. Now let's combine everything that we have learned and build a number guessing game. Let's understand it. The loop keeps asking the user for a guess. If the guess is wrong, try again is printed and the loop repeats. Once the correct number is entered, correct will be displayed. Python executes break and the loop ends. Now let's give it a try. As you can see, I have hard-coded the answer as 7. So first let's try like 75, it asks for it again, 48, and finally 7. And as you can see, it works just like we intended it to work. Let's review what we've learned today. Today you discovered why loop control statements are useful, how break immediately ends the loop, how continue skips the current iteration, how pass acts as a placeholder, the difference between break and continue, how these statements are used in real-world programs, how to make a for loop, how to make a while loop, what is range, what are nested loops, and at the end we utilized it all to build a simple number guessing game using break. I hope you've learned something from this, and I'll see you in the next lesson.